If you thought the latest images from the James Webb Space Telescope were the most breathtaking views humanity had ever captured, prepare to rethink everything. A different observatory has quietly begun returning data that is every bit as remarkable, and in some ways even more surprising. The images now arriving from the Euclid Space Telescope are revealing an astonishing level of detail, exposing enormous cosmic structures that astronomers are only beginning to understand. These are not simply beautiful photographs of distant galaxies. Hidden within them are immense patterns shaped by invisible forces, faint objects that escaped every previous survey, and clues suggesting that the universe is far more complicated than our current theories can fully explain. Today, we're going to explore what Euclid has discovered, why scientists believe its first observations mark the beginning of a new era in astronomy, and how these incredible images are changing the way we think about the cosmos. Stay until the end, because what you've seen so far represents only the smallest fraction of what this telescope is expected to uncover over the coming years. Unlike telescopes designed to capture dramatic close-up portraits of individual galaxies or colorful nebulae, Euclid was created with a completely different purpose. Rather than focusing on isolated objects, its mission is to map the large-scale structure of the universe itself. The European Space Agency launched Euclid in July 2023, placing it nearly 1.5 million kilometers from Earth near the Sun-Earth Lagrange point 2, where it enjoys an exceptionally stable environment for observing deep space. From this distant location, the telescope can survey enormous portions of the sky while maintaining extraordinary image quality. Its wide-field instruments allow astronomers to photograph millions of galaxies in a single campaign without sacrificing the fine details that make scientific analysis possible. This combination of scale and precision gives researchers something they've never had before: the ability to study individual galaxies while simultaneously observing how they fit into the immense cosmic network stretching across billions of light-years. Yet the telescope's most important achievement isn't simply collecting light. Euclid is designed to reveal something that cannot be seen directly at all. By measuring tiny distortions in the shapes of distant galaxies, produced through the phenomenon known as gravitational lensing, Euclid can trace the hidden influence of dark matter. Although invisible, dark matter bends space with its gravity, subtly warping the light that travels through it. Those tiny distortions become a map of an unseen cosmic framework that has remained largely hidden from human observation. In many ways, Euclid is allowing scientists to examine the invisible scaffolding upon which galaxies, galaxy clusters, and the entire large-scale universe appear to be built. When the mission released its first large mosaic of the southern sky, researchers immediately realized they were looking at something extraordinary. During a relatively short observing campaign, Euclid captured hundreds of individual exposures covering an area roughly 500 times larger than the apparent size of the full moon. After these observations were combined into a single image, they revealed an incredible landscape containing millions of stars within our own galaxy alongside millions of distant galaxies spread throughout the observable universe. Even more astonishing is the fact that this enormous mosaic represents only about 1% of Euclid's planned sky survey. That means the breathtaking image scientists are studying today is only the opening page of a much larger cosmic atlas that will continue expanding throughout the mission. Every future observation will add another enormous piece to an increasingly detailed three-dimensional map of the universe. Researchers can already zoom from gigantic galaxy superstructures down to individual galaxies without losing remarkable clarity. Few astronomical surveys have ever provided this combination of enormous scale and fine resolution. Instead of acting as a simple photograph, the mosaic functions as an immense scientific database. Every tiny point of light contains valuable information about distance, motion, brightness, and cosmic history, allowing astronomers to investigate how matter has been distributed across space over billions of years. One of the most fascinating early targets examined by Euclid is the Perseus cluster, located roughly 240 million light-years from Earth. At first glance, the image appears to be another impressive collection of galaxies. But closer inspection revealed far more than researchers anticipated. The telescope clearly resolved over 1,000 previously catalogued galaxies belonging to the cluster while simultaneously detecting more than 100,000 background galaxies lying much farther away. Then came an unexpected surprise. Hidden among the brighter objects were more than 600 previously unknown dwarf galaxies so faint that earlier telescopes had overlooked them completely. Although these galaxies are relatively small, they are incredibly important to cosmologists. Their weak gravitational binding makes them especially sensitive to the surrounding influence of dark matter. Their positions, shapes, and motions provide valuable clues about where unseen mass is concentrated throughout the cluster.